It is not very easy to follow the presentation like this one. This is one of the unexpected tasks, or let's say expected tasks, since I was asked to chair the session. My presentation will be different in nature. I am going to demonstrate or illustrate one experiment. I am going and try to actually illustrate one learning process, focusing on one area that is the area where I have a little bit more of understanding or personal experience, but area that has a considerable implications, I think, on the global level. So the issue I will be talking about is the issue of the water, and the issue will be addressed at the global level. In this particular presentation, after the short kind of introduction, I would like to talk about one attempt to do the experimentation through the development of the system dynamics world water model, and present some initial results of the analysis I've been doing and illustrate them with a very short set of conclusions. This work is not completed yet, and I am quite happy, I would like to say, with the results which are coming out of the model, and I would like to share and hear your opinion about them, because they are indicative of the typical systems approach to a global complex problem where you face unexpected results or behavior of the complex systems. So the main approach being used is system dynamics, and many of you are very familiar with the concept, and the motivation came from the development of the World Tree model developed by the MIT group through the work of Meadows and other collaborates, very well published and known through the two books, Limits to Grow in 1972 as a consequence of the work of the Club Rome, and the second book in 1992, follow-up book in 1992, Beyond the Limits. The purpose of the development of World Tree model was to understand the possible modes of approach of the human economy to carrying capacity of the planet, an honest objective, but obviously very complex and difficult task to achieve. Number of presentations, I think, in our keynote lectures and the presentations in the afternoon parallel sessions, we're tackling different issues related to the complexity and difficulty in looking at the global level, the needs or pros and cons of looking and modeling global issues. What I was motivated by was a relatively simple fact that this complex process and the development of the model covered these 5 sectors and didn't explicitly touch an issue that I'm very sensitive to, the issue of water. The persistent pollution is incorporated in the model, non-renewable resources, population, agriculture through food production, land fertility, land development, loss through erosion, and so on. Economy through industrial output, services output, and jobs. But no explicit consideration of water, even that water is actually touching all of these different sectors. So being kind of puzzled why that was done, I have contacted the authors of the world model and had a small communication, and got on my proposal to maybe attempt to do something together, got the question back from Professor Meadows asking me, what is the issue? So I must tell you, I was puzzled with the question. I thought I am missing something in my view of the world or my knowledge of the development of the water resources, or I am missing something in understanding the global processes and the model and attempts and objectives which this particular model wanted to do. So in an attempt to kind of answer that question, I decided to do some work. And what I have done, I wanted to demonstrate, actually by answering the question of Professor Meadow, that the water plays a role at the global level. So I would appeal that you don't accept the results of this work and this presentation as the solution and answer to many problems related to water resources management, use, abuse, and development, but an attempt to look at the water at the global level. In my field, at the meetings and the conferences I am attending, the facts being presented are overwhelming. So the motivation for doing this work, I can pull out a couple of main issues. 31 countries facing chronic water shortage, possible increase of that number to 50 by 2025. 1.2 billion people lacking access to safe drinking water. About 3 billion people lacking adequate sanitation, and so on. In February of this year, the World Water Council organized the Water Forum, which was attended by more than 1,000 participants, people from all over the world, ended up with unveiling the World Water Vision, which provided some projections for year 2025, indicating that the water is really becoming an essential issue that is going to play considerable role in socio-economic development or the future of the planet. I approach this particular problem to kind of looking the global water balance. And if I look from both sides of the fence, considering that my side of the fence will be the area of the water resources engineers, experts, people who are carrying the knowledge and doing the work in this particular field for years, and the other side of fence are the people with other expertise in different fields that may have and may relate to water. It's interesting to see that even the water resources specialists are limited by our knowledge and the way how we approach the problems. This is a very classical graph which I'm using to illustrate our ability or inability to correctly predict the future. This is the line is obviously indicating the actual global water withdrawals, and these different points are the projections, the future projections of the water withdrawals, and you see the range within these future projections are, and the range in this particular graph is created only based on the length of the period in the past we are using to make our projections. So if the problem is not being moved to another level, to look at the interrelationships between the water and other elements that are directly affecting it, I think we will be basically still remaining in the dark, not knowing in what direction the use of this particular important resource is moving. I'm sorry for this busy graph, but this graph is just used to illustrate the structure and the approach how I was planning to attempt to add or modify the world stream model by adding and considering the water in it. What you see in the middle is the part which I am very much kind of concerned with, the water stock affected by the use and the supply from oceans, non-renewable resources, renewable resources like precipitation and so on. The remaining blocks are basically the blocks from the World Tree model. All 5 of them are here: population, industrial capital or industrial development, agriculture, food production, and pollution. And what I have attempted to do with these arcs and graphs and pluses and minuses is to identify the loops, positive and negative feedbacks that relate the water to other sectors being addressed in the development of the World Tree model. And you see that obviously number of interconnections is pretty high. That's basically expected. The population is affected by the availability of the water because we need water to drink. The outcome, affects the level of the pollution because we put the waste into the water and then dispose that waste into environment. The industrial development and growth is also affected by the availability of the water which is required to support the processes of the industrial and so on. The food production is tremendously dependent on the amount of water required to grow the food, irrigate the land, and so on and so on. So this is the kind of structure which is being followed in the development or modification of the world water model. The structure is developed in a very classical water balance way. I looked at the two sides, the resource side and then the water consumption side. On the resource side, we were looking at all these different possible sources, renewable obviously first, then non-renewable groundwater, water reuse as one possible way of dealing with the issue of conserving, and then desalination of oceans or seawater. On the consumption side, I try to cover the ground by looking at the municipal water supply, irrigation, industrial water supply, and also one important aspect which is not quite often considered, the loss of water through the evaporation from large water bodies artificially created from world reservoirs. In order to look at the development of water, in order to understand the impact and the relationships between the water resources and other sectors being considered in the World Tree model, I needed to develop and use a particular set of principles. The water issue will not be resolved on the global level. I think Professor Mesarovic said the planet will not disappear. But Africa is already thirsty, and I think it's a similar situation. We have a population in the particular regions that simply does not have sufficient water, and we have sufficient water in the regions where we don't have population to use it. But there is no easy way to go over the ocean and bring the water from Canada to Africa, or to move the population of African countries, to North America and so on. So I use the particular principles to look at the picture at the global level, and the principles are the hierarchical use of the available resources. These principles are self-created, and I think they are simply following the common sense. That first, if you are looking at the global picture, we will be focusing on the use of the renewable surface water resources, the water which comes and renews itself over the period of time through the precipitation, and you have some figures. Indicating the amounts or the data that I have used. The second level of the hierarchy will be exploitation of the water which is not renewing itself so easily. These are non-renewable groundwater. Right now, these resources are already being tapped in northern Africa, in many Arab countries. And the capacities currently, you can see, being used. Water reuse as a third level, which I am kind of incorporating in this hierarchy of use, where the variety of the kind of water reuse rate is being kind of condensed into a simple number of 20%, which I am considering to be something like an average from the current reuse rates in different countries. But the numbers vary between 7, 8, and 50, let's say in Israel, 55 in Israel, and so on. And the desalination in this particular attempt, which I am describing right now, is limited to the current capacity as indicated here. Obviously, you realize that there is no limit except to the volume of water we have in the oceans to this particular source. However, there are considerable economic consequences of using this particular source as a main source of kind of augmenting the deficiency we may create between the demand and available non-renewable resources. So the next step after developing and using these principles was to link the two components or sectors. Actually, I have added two sectors to a World Tree model. One was dealing with the water quantity and another one was dealing with the water quality. And you can see through these two slides number of interrelationships which I have developed. The relationships or simply links between different sectors of the World Tree model and the modified World Water model, where the data on the population and the principles of the population growth sector were used in correctly estimating the necessary demand for the municipal use, or the impact of the level of the municipal use on the life expectancy is fed back into the population model to affect the population, the calculation of the population growth and so on. The similar information is shared between the food sector or agriculture sector and the need for water for agriculture, as well as the industrial sector and the sector of water related to the needs of water for industrial needs of water, as well as the urbanization or the movement of people towards urban areas in obvious search for jobs. And finally, the pollution index or the pollution sector is also related to a water sector, so that the level of integration I was able to reach between the water sectors and the remaining sectors of World 3 model was achieved through the development of these relationships. I must tell you that this was not an easy task. The databases I was working with are very limited. To develop these relationships, considerable amount of information, reliable information is necessary if we are seeking or looking for reliable answers. And types of relationship like this, which is kind of identifying the link between the municipal use per person and the life expectancy, was not easily was not the piece of information that you can easily find. However, I followed the principles of the system dynamics and the basically group which introduced this particular approach, that sometimes the shape of the relationship plays quite important role in understanding the dynamics. And even if we do not have a reliable numbers, so if the numbers in these two columns are not exactly telling us, what will be the impact on the life expectancy, we do feel comfortable with the shape of the relationship and the behavior which will be the consequence of this type of input on the final behavior of the complex system is captured. I'm not so what I'm trying to say, I would like you to accept the final results with a grain of salt, in a way that I didn't have all the necessary data to confirm every number being obtained. But I feel very comfortable with the behavior and the shape of the kind of relationships and the data sources being used. Let me just quickly illustrate the results. I think I'm going to finish on time. This is the part of the output which is related to water sector, and I used only these are different colors in identifying the use of water for different purposes: green for our agricultural production, black for industrial use, brown for municipal, blue for reservoir losses, and purple for water necessary for transportation of or for the dilution of the pollutants. Something is very symptomatic in this particular graph. The numbers and the stars and crosses you see here are taken from the two widely quoted predictions and documents available in this field. The stars are coming from the UN document, the global assessment of the water resources, being the product of a number of UN agencies and a large team of world experts that ended up by assessing the existence, use, and availability of the water resources and providing the prediction for year 2025. And the crosses are the data and predictions obtained through the World Vision process, UNESCO-led project, which was unveiled in Hague in February of this year. And what we are seeing here is the considerable difference between the results I have obtained, especially in the industrial use, in the municipal use, and obviously underestimation in the field of agriculture and irrigation water use. I think I do have the answer. The predictions being made here are totally independent on the processes which are occurring in the industrial development, in the population growth, in the food production. These predictions are being made on the per unit use of water and predictions of the population growth. not the model of the population growth, or the prediction of the industrial growth, not the model of the industrial growth. So I feel very comfortable that the modeling results representing this kind of graphical behavior over the period of time is capturing the character and the development of all these different sectors that are affecting the water resources. One important final result is the existence of this purple line, which, if you look at the numbers on the left side, is really alarming. The predictions being done by my colleagues, respected colleagues, didn't at all consider the necessary clean water to be used to dilute the polluted water. In this particular modeling effort, that was indicated to be the most critical issue. Let me quickly just compare now the analysis and finish my presentation by this comparison. The World Tree model was ran with the 14 different scenarios. They are published in the book Beyond the Limits. And these 14 different scenarios are kind of projections of the possible development of the world being affected by acceptance and integration or introduction of different policies. What I have selected for the comparison and making my point was only one run. The run they called in the book, kind of stable or sustainable run. And this particular run is characterized with what you see here. The development which continues with stabilized population and industry, in addition to implementation of new technologies to conserve resources, protect the land, increase land yield, and reduce the pollution. The consequence of this particular set of policies is represented in this graph with the population in a red line reaching some kind of stable level of about 8 billion people by 2000 and remaining stable by stabilized food production at this level, industrial output at this level, and so on. Now, how can I go back? Now, after running the World Tree model, I wanted to see what are the consequences of introduction of the water sector and what the water is now going to do or is doing to these particular results obtained through the world model in original form. In this particular run, again, certain set of conditions are being followed. That water use continues with the current rate of growth in municipal water demand. The irrigated land stabilizes around 15% of available arable land, and pollution is mostly dealt with by providing clean water for dilution. Please try to remember this graph and see the change. The change is, it was surprising to me. I spent 25 years working in the field of water resources, and I was expecting that the main output is going to show the deficiency of the amount of water necessary basically to supply the demand. What actually happened was that the increased level of pollution and the use of simply or dumping the polluted water into the clean water and the necessary clean water to dilute that to acceptable level was affecting the performance of the model the most. What we ended up with, as you can see, somewhere after 30 years, the considerable drop in the population. So no way of supporting 8 billion people as the world model was indicating. Considerable drop in the food production because of the obvious lack of water for irrigation and so on. Industrial development and so on. So I have two more graphs, and in order to give you a chance to have a coffee and chat a little bit, these two graphs are showing basically the same impact, only using different variables for the illustration. I would like to end up my presentation by saying that with this particular experiment, I think I achieved the learning and understanding and increased the understanding of the interrelationship the water has with the development. And I think the model has demonstrated that water plays an important role in dynamics of growth on the global scale. The surprising conclusion and the fact was that the water pollution is one of the most important global issues that is going to affect the total water resources in future. With this in mind, thank you very much.